我也不知道，因为没有一个人会说 OK， 我考得很好。对，就或者是啊，应该说正常吧，正常。就有没有人就是大家写到，大家什么时候开始就是陆陆续续交卷？很少是不是？不好意思，蛮少人的哦，蛮少人提早交卷，就大家都写到满就对了。OK，哎，我忘记我最后一题有没有出我自己的名字了。会写吗？会啊，真的啊，我还蛮讶异的，因为对，因为其实我很久以来都不太有人会写我的名字。然后我有一次啊，出自己的题目，就自己的名字当题目，然后我就什么3分吧，被骂到臭头哎、学员就说哪有这回事，什么，为什么可以出这个题目当分数？然后我就想说，哇，大家都好激动啊，3分啊，anyway，后来我就不敢出分数了，就0分。好，OK， so let's continue our lecture. Right. So last time we talked about the side convention of the shear moment diagram. All right. So because we are going to draw the shear and moment values throughout the material from the left point to the right point. So we need to get the internal shear and moment in the material. So when we need to get the internal shear or moment or any other force, we just need to cut it, right? The only thing we need to uh, pay attention is we need to leave the left hand side. Okay, we leave left hand side. We are not going to leave right hand side in this chapter. I mean, in this chapter 4 and chapter 5, because when we are drawing the figures, we need to we need to draw the value when the shear going down is positive, moment going up is positive. All right, so we need to choose this rather than this. All right, so this you need to be really careful. Although this is a rule, sign convention, actually there's no physical meaning why you choose left hand side or right hand side. Both are okay. Both are equivalent. Okay, so actually in maybe Europe, they choose the right hand side. So when you study in different country, you may end up has different opposite diagram in shear moment diagram. All right. So when you study in other countries, you may encounter these different things. So yeah, again, we choose the right hand. We choose leave the left hand side and draw the value of the right hand side. Okay, so it's a little bit, yeah, right. So we also introduce the example that we are going to draw, I mean, calculate the V and M, shear force and moment, left of the midpoint and right of the midpoint. So you can see the reason why we're going to see this example is that we're going to see how a moment, external moment, additional moment will change the shear and moment. Okay, so when you from the left hand side to the right hand side. Okay, so we cut the left hand side. So this is the uh, force diagram. We leave left hand side, right? So cut, and then we have this. All right. And then, yeah, we can just do the force balance. Oh, by the way, before we do the cutting, we need to determine reaction force first. Okay, so after you see the loading shown in figure, showing the problem, and then we need to determine how many reaction force supported by the given by the support, and this is the hinge, so it gives us two reaction force, horizontal and vertical. However, the roller only give you vertical. All right. So after you do the moment balance, or shear fx or fy balance, you can get a bv rav. Okay. So now after we cut it, and we can have this p and rav and v and m. And V and M will be our answer. All right, so let's determine that. So very easy. Shear force V. All right, so sigma Fy equal to 0. So Ra minus P minus V equal to 0. Okay, you see, although the V here in the diagram, it will be positive, but you see, when we do the force balance, it still follow the rule, the system we used to use. Okay, you see, V is downward, but in the force balance, it should be minus V. Okay, so this is a little bit, you need to be careful about this. The only place that V going downward is positive is shear diagram. All right. So this is a little bit, something we really need to be careful. So minus P over 4 minus N no divide by L。这边有没有听懂？就是说啊，我们画这个 shear V 往下，对不对哈？我们那时候是说啊，我们大家 shear diagram 要往下为正，对哈？但是你看，我们假设往下为正以后，然后我们在做一般的力平衡的时候，又回到我们以前的系统的状况喽。真的只有在画简历弯曲图的时候，我们留左边画往下的 V 是为正，就只有这个是一个特例，其他的就小心哦。你看像这个 force balance 力平衡的 V 往下，我们还是要减 V 哦。这边真的要小心。Okay, so let's continue. So we obtain V. How about moment? Moments here. Moment. M. So sigma M. Where? M blue dot. Okay, the blue dot equal to 0. So RAV and times L over 2. And what is the sign? RAV to the clockwise, so it will be minus. And P downward also downwards is become counterclockwise about the blue dot. So it should be a plus PL divided by 4. And okay, M no here. Sorry, not M no M. The M here is in the counterclockwise. M itself is counterclockwise, so it will be positive, equal to 0. So our M equal to PL divided by 8 minus M naught over 2. So these two values are the answer. Okay? So see, these two values is the answer. All right. Sorry, I shouldn't use yellow. I should use blue. Okay, M and V. So we obtain that values. Now, let's do exactly the same thing and cut the second cutting. All right. So the second cutting we draw here. Okay. And sorry, I should directly draw the force, should be more than enough. M no. And we assume this cross section has the downward V as positive and upward M as positive moment. Okay, and we also see the P in the left hand side we left, and we have RAV, of course. So you can see that the only thing different is we have M no here. You compare the first problem and second problem. The only thing different is our blue point is kind of exceed the black point M no. Okay, so you see the slightly different, and of course it will affect the force balancing, right? So we do exactly the same, and then you will see the difference. Shear force V sigma Fy equal to 0 and Ra minus RAV minus P minus V that equal to 0 and V equal to minus P over 4 minus M no divided by L. Oh, you see that these two values are exactly the same. So which means that if you apply the moment, external moment, M naught in whatever it is, it won't change the value of the shear. See, doesn't change at all. Let's check the moment. Moment M. Sigma M blue point. Although this blue point is not the same as the first problem, okay? Because you see there are two. Sorry, I shouldn't use blue. I should use dark blue. Sorry, I changed the value. Let's change the color. All right. You see, this is dark blue, and this is dark blue, and this is light blue, light blue. Okay. Yeah, I should make the color consistent. All right. So next, we do balance. Minus RA L over 2 plus P L over 4 minus M no plus M. Okay, so you see that. Let's compare a little bit about this balance, these two balance. Almost the same, but more one additional term, minus M no. What is a minus M no? Of course, this is M no here, and it will give a clockwise moment. So it has minus M no, okay, in this balance. And then we can obtain the M here equal to PL divided by 8, M no divided by 2 with the plus sign. Okay, so you notice that, okay, you notice that the M here has a difference before M0 and after M0 applied in the material will give you a moment difference M0 itself. You see? Here is PO divided by 8 minus N0 half. And right hand side, after the N0 is PO divided by 8 plus M0 over 2. So the difference is N0. Of course, this N0, the contribution of this difference will be this external M0. Okay, so you can see how the moment changed due to the external force or moment. All right. And also you can see that if you apply an M0 with the external M0 is clockwise, which means that your cross section need to be balanced, need to balance it. So you will have the opposite direction of this clockwise moment. So your moment will become counterclockwise here. And of course, it will make it smile, right? Smile curve. So you see that your clockwise apply moment will make the moment in the material become positive, more positive. Okay, so of course the value will be the external force, external moment value. OK， 好，这边讲一下中文，我觉得这边有点复杂啊，就是说你有没有发现，在 M0之前它是这个 M 值，但是 M0有 M0这个外加弯矩之后，它就多了 M0了，它就变成 PO 除以8加 M0除以2 ，OK， 它就变成多 M0。这个 M0当然就是你外加的 M0的贡献嘛，这个差别当然就是因为外加弯矩的贡献。好，那这时候我们就会想说，哎，它这个弯矩从这个材料内部的弯矩是从左边到右边是加 M0，也就是说你可以看到这个外加的 M0是顺时针的。这个顺时针的呢，你要想看哦，这边顺时针多了这个顺时针，你为了让这个材料平衡，你的截面一定要有一个逆时针的 M， 才会去抵消掉它。所以你可以发现，而且这个逆时针的 M 抵消掉它的话，它就会加上去嘛，对不对？因为它是正，它是微笑曲线，对不对？哈，所以说你的右边的 M0。就是右边的 M 是加上 M0，不是减掉 M0。好，所以你可以用这样的方法去思考你的外加弯矩是如何让你的内部弯矩加或减，只要小心哦，你要想象一下，把外部弯矩抵消掉的方向，就会是你的内部弯矩的状态。那这时候你就可以看那个方向来决定它的正负号。哦，所以这边要想，所以你可以相信，就你可以看到哦 ，M0这边是逆时针，好，不讲错了，顺时针。为了要抵消它，我的内部弯矩就是要逆时针。好，我们的 M0是顺时针的话，我内部弯矩要抵消它，就变成逆时针。那这个逆时针，你会发现，哎，那就是微笑曲线。那微笑曲线就会让右边这个弯矩其实是会比左边的弯矩多了 M0加上去的。好，所以这边要想一想。好，因为以前的学长姐，没关系，以前的学长姐都会觉得说，我不知道加了这个就外加弯矩这个 M0，我接下来的右边是要加还是要减，知道？所以你这边也可以用，就考虑看看。OK， 好 ，Right， so let's continue. Sorry, I think I may skip this. Okay, skip this and move to, let me take a look. Okay, move to later. I will change a little bit. OK， 我改变一下顺序了哈，就是不好意思，就是这一页就直接接到下一页啊，就是那个标题简历之间的关系。好，我把那个题目往下放到结束，就是这里，放到我结束这边那个 moment 讲解完以后，就是刚刚那一题，然后你就会发现，哎，有2题是一模一样的哦。好，就是这样。Okay, I was just switch the order of the page. I changed this page. So you will see two identical problems. Okay, so I will show you solution 1 and solution 2. All right, so sorry, I just changed a little bit about the. All right, so let's continue. So let's take a look. What is the relationship between loads and shear forces and bending moments? All right. So you just see how the external load will change the internal shear and moment in the material. So let's take a systematic way to see that. All right. So what if we apply distributed load on the material and how it will affect the internal force and shear force, internal moment. You can see that at the left-hand side, there's no distributed load. So this is the original, the left-hand side that happened before, okay, in the past. And when you encounter an external load, which is distributed load, what will it affect to the right-hand side? So this is what we are going to see. 这边我也觉得蛮复杂的，讲中文哈，就是说，如果你左边是你还没有遇到这个外加力的，那我们现在就要看，所以左边的 VNN 就是你从之前的事情啊，哈，之前的你既有的剪力跟弯曲，但是当你一遇到一个新的应力，新的力，不同种类，这边是分布载重，如果你遇到分布载重，你右边的剪力跟弯曲会以什么样的形式增加或减少？就这个 distributed load 分布载重会影响你的剪力值跟弯曲值多少？这就是我们现在要看的东西。All right, so if we have the distributed load Q upward, okay, so what will it change the V and M? So the change due to the Q, of course, is dV and dM. So you can see that this dx, okay? So it has a small dx, and on this dx, you have a distributed load, Q. So you have a Q dx, and of course, Q dx is a effective load, right? And of course, the length will be the position of that load, and the blue dot it has dx divided by 2 direction. Again, I will remind you the dx is the length scale, length, and the q here is Newton divided by m, the unit, okay? So now you have the force, effective force, q dx, and you have v, and you have v plus dv, m plus dm. So this element need to be stable. So you should do the force balance, right? So you see sigma Fy equal to 0. So your V upward plus Q dx upward, okay? And minus V plus dV minus, okay, equal to 0. Ta-da! All right, so after you cut, do the, okay, and then you will obtain dV over dx equal to Q. What does that mean? dV equal to dV over dx equal to Q. What does that mean? Okay, I will write down what does that mean. I will conclude 6 conclusions to help you to draw the shear and force diagram. All right. So you see, dV over dx. Don't you think this is a slope of a x and v diagram? Okay. The slope of the shear diagram is the value of the distributed load. This is very important. After you memorize this, you will save a lot of time when you draw the shear moment diagram. Maybe you will think, what does that mean? Don't worry, I will show you an example and then you will immediately get this. But we're using the force balance, right? And then we can get the dV change related to the Q here, okay? And dV over the dx equal to Q. And dV over dx actually is the shear diagram. What is shear diagram? It will look like this, X and V, okay? And then, so you see this value, dV over dx is exactly the slope in this diagram. Okay, so you will use that later. And then the second thing is that if we put the dx to the right-hand side and then to do the integration from a to b, what is a to b? Well, a to b is just the random 2 points in a range because the dx is just a little, this is not actually a length. It's just a infinitesimal, small distance. And when we are talking about a real length, we need to do the integration, right? So the a and b, whatever point, a, b, dv, a, b, d, q dx. And then after do the integration, we have vb minus va equal to the a, b, q dx. What does that mean? It means that this is shear force difference between 2 points, between A and B. And this Q dx, do the integration from A to B, is actually area of the distributed load. So simply speaking, is the area of the distributed load from A point to B point. Okay, so we have another conclusion. The change of the value of the shear force is the area of the distributed load. Okay? So we have two conclusions based on the distributed load balance. 好，这边再讲一下中文，我觉得这边超重要的，就是说，你原本的简历跟弯举在左边，在你之前，然后在遇到这个 Q 之前是 V 跟 M， 它只是多少先不管啊，但是遇到 Q 之后，你应该一定会有变化，所以你的变化就是 V 加底 V 跟 M 加底 M。那我们就做力平衡，发现哦，dV 跟 dx 等于 Q， 表示说，哎，那就是斜率啊 ，dV 跟 dx 就是斜率，你有没有发现？就是简力弯曲图的斜率，也就是说，到时候那个斜率啊，就会跟你的分布载重的值是一样。那再来，我们做了积分以后，你就会发现积分，因为刚刚那个只是一个小小变化，那不是一个真正的距离，我们要真正的距离要积分。那我们从A 点积到 B 点，那 A 积其实没什么重要了哈，就是随便两个点，这两个点如果这两个点可能是应该是这个分布载重的距离啦哈，所以从 A 点到 B 点这个分布载重距离在分布在上面的话 ，VB 减 VA， 也就是说这两点之间紧密的差距正好就会是这个分布载重的面积呀，分布载重的面积。那对啊，所以就是说。经过一个分布载重，你的简历的变化量就会是你在上面分布载重的面积值。所以其实到最后，等下之后画图的时候，你根本不需要去力平衡了啦，你就记这些规则，你就可以画出来了啊。到时候就跟大家讲。So the point is that after we do the proof, later when we draw the figure of shear and moment diagram, we don't need to cut it and do the force balance. No, we just need to memorizing, apply all these conclusions I highlight in yellow. Okay, and you will draw the figures very efficiently, very quickly. All right. Continue. A distributed load after the shear. After we have know that what is the distributed load down to the dV. How about the M? So we do the sigma M blue dot equal to 0. So you see M here is clockwise, so it's minus M. And Q dx rotate about the dark blue dot is counterclockwise, positive. Q dx times dx over 2. And V dV clockwise, so it's minus V plus dV times dx. M plus dm is counterclockwise, so it's positive M plus dm equal to 0. So you obtain the result is that dm over dx equal to v. Of course, we need to, cancel. All right. And then, you see here, right? You see dx and dx, these two values are so small, so they can be when they times together, so it become negligible. Okay, and you see that dv and dx times together, it become two small things, negligible. Okay, so you will end up dn over dx equal to v. Again, you see dn over dx is slope in moment diagram. Okay, so third one, the slope of the moment diagram is the value of the shear. Very important. See, your moment diagram slope is the force value. So now you can see how the shear and moment correlated together, right? The slope, the change rate of the moment is actually the shear value at that point. Again, we do the integration for that. And so MB minus MA equal to this one. So moment difference from A point to B point is actually the area of the shear diagram. Okay. Right. So the fourth conclusion. The fourth conclusion. The change of the value of the moment is the area of the shear diagram. Shear diagram. Diagram. Okay. That's it. So your moment is actually strongly correlated with shear. The moment 啊，跟 shear 超有关系的，因为你的 moment 的斜率就是剪力当下剪力的值啊。So we have in total 6 conclusion. Okay, 6 conclusion. Yes, right. 1, 2, 3, 4. Yeah, 6 conclusion. Now we introduce 4. Okay. And yeah, we will introduce more later. 6 conclusion will help you to draw the figure diagram of shear and moment diagram. Okay. Really in a really elegant and efficient way. Okay. 也就是说，以后你画图的时候，你就不需要再去剪来切来切去了，你不用去地平衡了，就记这些6个我们推导出来的结论，然后就可以直接画出来了，或者是优雅的画出来，而且又快速的画出来，很好玩哦，我觉得啦。对哦，跟大家公告一件事情，下礼拜3我不好意思，我要请假，对不起。那所以应该会有50分钟，我就是欠大家。那其实是不能就让他就是不上，因为16周已经本来就很少，所以一定要上。那所以应该，但我不想找时间给大家补课，所以我想要提一个意见，就是说是否能不能往后的礼拜3上到10点。也就是说，以后的礼拜3上就5个礼拜3我都上到10点，就是补那10分钟、10分钟、10分钟，分在5个礼拜补，这样可以吗？好吧，有没有意见？应该是没有啦哈。对，那也就是下礼拜3我没办法上课，所以下礼拜3停课。那我这个措施会公告给大家哈，我会停课，然后但是在之后的礼拜3，我会有连续5个礼拜3会上到多上10分钟，那就会补足那5分钟 ，OK，补足那50分钟，好 ，OK 吗？好，So I just want to let you know that next Wednesday I cannot give the lecture, so we cannot have the lecture that day. So I will owe you 15 minutes, and I will distribute it this 15 minutes into the rest of the 5 Wednesday. Okay, so next 5 Wednesday we will have 1 hour lecture to have the 15 minutes extra for the hour I owe you. All right, so I will announce this in the Facebook and the E3. All right, so let's continue. 4 minutes. So how about point load? This is point load. 没电了，我的笔没电了，看它能充多快？据说是15秒，对不对哈？15秒之后就可以再用，这样。啊，跟大家聊一下 AI 好了。最近不是有一个词叫做 vibe coding 吗？大家知道 vibe coding 什么意思？vibe coding 就是8岁小孩，讲我们来做个游乐园吧，然后就跟 AI 讲，然后就做出一个游乐园，对不对？哈，然后他都不会写程式啊，然后就可以做出来，这叫做 vibe coding。然后这让我就觉得，我就想要就就是也不是蛮担心，就是我在犹豫要怎么样去教我下学期的技概。大家知道我技概就是目前已经就是没办法再跟那个 Jerry 合作了嘛，哈。然后我觉得这是一个好机会，就是说每5年我的课程应该都是要去重新去修正一下，就是因应一下时事嘛，对不对哈？尤其是计算机概论这个课，材料力学的话，那这是经典，所以应该是永远不会变的这样。但是如果是计算机概论，就是现在就 AI，那是否我就不需要教大家就是好好的写扣呢？还是教 AI 写就好了吗？所以我现在正在思考这个问题。我在积极的跟同学啊、学长，就你们的学长姐去规划，就是下学期的技概开始要怎么上，应这个 AI 的时代。那我想了很多了，还蛮有趣的。不过我后来想到 vibe coding 对不对哈？其实我发现，我 vibe coding 已经11年了，你知道为什么吗？我当教授已经11年了，所以我当了教授以后，我就没有时间自己写 code。所以其实你们就是我的 AI，就是我的学生们啊，专题生们，这你们就是我的 AI，我就是 vibe code，我就说，你要做这个，然后做出来不太对，然后你要去修正，这个不太对啊，你要修正，这个错了，我要怎么解决呢？当然你就会给 AI 指示嘛，在 vibe coding 的时候，但你不觉得我就是我们教授就在出一张嘴嘛，对不对？那 vibe coding 也是出一张嘴，对不对？所以哇，这完全一样的事情所以我后来发现你要 vibe coding，其实好像也不能不写过程式哦，因为如果我没有写过程式，我无法跟写出程式，然后如果有错误或是没有解决问题的时候，我如果没有以前写过程式的那些经验，我可能就没办法帮助大家了，对不对？所以这可能是 web coding 的一个对，就这样，就是蛮有趣的一件事情。好，那就这样，好，那今天上课上完了，好，就这样，谢谢大家，拜。所以到底可不可以写了呢？可以了耶，好，哇，刚刚我讲一下话就已经28%，这充电也是蛮快的。OK，怎么了？忘记了哦，做过头这样，辛苦了，辛苦了。我刚刚我当下我就以为就是说，今天是停课吗？因为没有人来。 你还好吗？会不会太